Welcome back, everybody, and NAT. Let's do some more NAT. All right, so we're going to be doing a couple of different variations of NAT. So we're going to start off with static NAT, where we do a one-to-one translation, and which means it's going to be all TCP and UDP communication. So we're going to start off by fixing the server here. So you'll see right here we have server 2, that's the ping is dying. So that'll be the first thing that we fix. And if we go through this, we need to remember that we're going to be using auto NAT, so object-based NAT. But this is, instead of using dynamic, we're going to be using static and going from there. And anytime we do a NAT translation, the static variable will come into play, where it's going to be a one-to-one translation. So once we set that up, that server is no longer going to be using dynamic NAT to communicate outbound. It'll be using the static NAT entry. And we'll see exactly what static PAT looks like as well once we get a little bit further along and do all of that cool stuff. And then we'll also have to worry about the access list variable as well, because now we need to, we have traffic coming in from the outside, going to the inside, but from a logic perspective, from the high security level to the low security level, we didn't have an existing entry in the NAT table. And if we do a show con long, we don't have anything there. If we do a show xlate, we have a couple from this, which is the entries in the NAT table going outbound. So these are just dynamic entries. So I'm going to go ahead and clear xlate. So if you're going to be playing around with these technologies at home in your lab, make sure you do this so you don't get inconsistent results. So one of the things that I'm going to go do is on here, if we go to IIS server, here it was working. Go ahead and pull this down a little bit. If I hit the, this time now in server test 12's website, neither one of these connections are coming in. But if we do a show con long, I believe will show us, show xlate, there's nothing in the table that's going to allow them to come through. Okay? So, with that being said, we're going to go ahead and do a show run object, and we're going to go underneath, we're going to do this for server 2 first. So, when we're doing this, you want to be doing this underneath of the object that you want to be allowing communication for. So in this case here, I have private server 2, which is 172.16.30.10. So I'm going to come in here at the enter key, and I'm going to type in NAT, and then again, this is where it gets a little confusing, like I talked about in the previous video, where it's like, okay, what address do I use? Do I say is it the flow of the traffic? Is it outside to DMZ VLAN 30, or is it DMZ VLAN 30 to outside? And in this case here, when we're talking about object NAT, it's always the source first. So I'm sorry, it's always the real first, which means we have to specify the DMZ and then the outside. And the reason why is because the traffic is going to be bidirectional. It's going to be both in to out and out to in. Well, I'm doing the motions wrong. But now, out or in to out will work out of the gate, right? So it'll in to out will work automatically because the traffic flows are supposed to go that way. For the in to out, other way around, out to in to work, we need to create an access list that's going to allow that traffic to come through. So in here, we're going to type in static, and then we need to specify, okay, what are we going to be doing here? Do we say the interface? If I type in interface, it's actually going to squawk at us. It says all traffic destined to the IP address of the outside interface is being redirected. Well, that's not good. I don't want that to happen. So I've actually got to go ahead and type in no to this command because I do not want all traffic to be redirected. What I will do is this. I'll go to the end here, and I'll pull this out, and I'll type in NAT DMZ VLAN 30 outside, and I'll come in here and I'll type in static, and now I had to specify the object group here. I'm going to specify. You can either type in an IP address or an object name. Now, by going back up to the objects, we already have the outside defined. We have the public server 2, which is going to be the public IP. It is a private address in my example because everything's internal to my network. But in this case here, it's going to be the outside IP address that for the subnet that the ASA has configured for the outside. So I'm going to type in that command and hit the enter key. And that's all I have to do. Now, the NAT entry is done. However, if we were to go and say, it's not going to, I don't want to show it right now because we're just going to get nailed with a bunch of ICMP errors, drops, is I still have server 2 trying to be pinged by PRTG. PRTG is on the outside of the ASA, which means once the NAT rule is configured and the access list is defined and mapped correctly, then traffic should be allowed to flow through. So I can come in here and type an access list. I can type an ACL in from outside and type in here, say extended permit, and I can specify from permit, in this case here, I can say TCP, I can type in IP, and I can specify the IP of any, so it's IP is a protocol, so the transport, so which is going to include TCP, UDP, ICMP, and everything else. And now I have to specify the source of the address. So in this case here, it can be from any source going to a destination of what? Now, and this is going to be the mapped IP address. So this is going to be the internal private. So I need to specify the address of public server 2. So if I go and do this, that'll be the logic that I need to follow. And if I do this, I have to say public, and the ACL is going to be the, okay, I don't want to limit it down to just the subnet, or I want to include the subnet. So I'm going to type in this case here, it's going to be object here, and then I'll say VLAN 30. So it's going to allow me to map towards the 172.16.30 network. And I have other options that I could use if I want to. So I'm going to hit the enter key, and then I'm going to type in access group ACL in from outside in interface outside. Now, what's going to end up happening is, and I don't know how long it'll take for the server to come up, but if we do a show xlate, we have a static entry from the inside to the outside, and as soon as we did that, notice how the ping started working almost right away. We do a show access list. We're going to see that there is one hit on the ACL. So the ACL is working, and it's doing its job. It's communicating the way that it needs to. Now, I am being pretty wide here. I could have said, you know what? I don't want to include VLAN 30, but I want to include server 2. So I could say, you know what? I can leave the ACL mapped to the outside interface, but I could say no ACL here, show run access group. Okay, it deleted that too. So I'll type in access list ACL in from outside, extended permit IP from a source of anything to, and if I scroll up here to the objects, I have the object of private server 2, and if I hit the enter key, actually I need to type in object there, object, and go to the end, and hit the enter key, that should work as well. So show access list, or access group ACL in from outside, in interface outside. If I do a show access list, that also has hits, but this is more specific, right? So we have that. So that's a static NAT, right? Now if I go to server 2 on this side here, the IP address hasn't changed on the inside. If I try to go out to the internet, do you think it'll still work? Yes, it will. And if I do a show xlate, I don't have any entries in here because it's a static NAT. But if I show access list, I'm going to have a bidirect 2 hits, so one going in, one going out. So, sorry about that, got interrupted a little bit. So, we have that. Now, let's ask the question, should I be able to communicate from my PC to the web browser of server 2? So I come in here, I hit the up arrow, and I hit the F5, and it pops up. And I come back here, I hit the up arrow, I have an entry. If I do a show xlate, nothing shows up because it's a static entry. But if I go back to this guy and I hit the Control C to block and I type in netstat-nao, we're going to see an entry here, right here. This is an established connection, right here. So that entry right there tells me that it is working. What's interesting about it, though, is when you look at it, you see my IP address. Now, in most cases, you would see the IP address of the mapped address, which would be the 10.1.10.100 address, or whatever public IP address you're going to apply. So that allows the NAT entry to go from the outside to the inside, and from the inside to the outside. So the communication is bidirectional. That's why when you look in the NAT table, it is a static entry. It's always there. It's never going to go away. It never times out. There's never an idle to it. Now, we take that same logic and we say, okay, that's cool. Now, can we split that out and go, okay, I want to make it so that it's the configuration is in such a manner that I can not just do a permit IP to any object. Yeah, you can. You can lock it down to specific ports. Absolutely. And then that would just be a matter of, and your NAT statement could still be pretty generic. It's the access list that's actually controlling what type of flows are allowed through. So I could come in here and say show run access list, and the access list is written the way that it's written. But if we do a show run object dash network, or dash group, sorry, we look at this, I have an existing connection option here. So I have the TCP flows. The TCP flows is one that is a object service group that specifies, okay, I have 1, 2, 3, 4, 5 port objects, web, SSH, FTP, HTTPS, and Telnet. So in this case here, I have those 5 TCP type flows ready to go, which means I should be able to connect to the device. Now, the PRTG ping is a ping. It's ICMP, which would be blocked if I was to do this. I'd actually have to go in here and do another entry to allow echo or ping, which I could do. So let's go ahead and add 2 entries. I'm gonna add those above the permit IP any object to server 2, just to show that it is possible or plausible, or not 100% possible for you to not have to do a permit IP. Although in most cases, I've seen that used widely because it just makes it easier to validate everything that's working. So what I'm going to go ahead and do is show run access list again, and I'm going to say access list. Let's see, ACL in from outside. I'm going to type in line 1 extended permit TCP from any source to an object of server 2. And I'm also going to say the object group, and I'm going to scroll up here to the top where the object groups are laid out, and I'm going to say, where'd it go? Right, should be right here. TCP flows. I'm going to say that. Then I'm going to click on that, and I'm going to hit the enter key. Now if I do a show access list, you're going to see that the access list now grew, and we have to be, it's a little interesting now that when we read this, is now we have web, SSH, FTP, HTTPS, and Telnet all configured, right? Now, since we have this defined, what we can go do, and you notice that the IP, the permit IP is down here now. So if I come back over here to this web browser and I resynchronize it, and I come back in here and hit the up arrow, we should have on the web connection right here a hit, which we do. There's a hit 1, which indicates that they actually had to go through. So we're no longer using this permit IP. So we can now go and type in no access list here and remove it. So this is your way of trying to lock down the access list after you get things running to see what is actually needed and what's not. You could do a log and then look at the log and stuff like that. So now we also need to validate ping, because right now ping is being dropped. If I was to type in logging enable and give it a couple of seconds, as a matter of fact, let me go ahead and just go in here and say scan now and go back to here. What should end up happening, okay, so the ping is timed out. I don't know why. Logging console debug. We should start to see okay, so ping has failed. So tear down ICMP connection. So we're denying an ICMP source. So this is what I wanted you guys to see. We're denying ICMP. And okay, so actually I need to do this. Logging console 6, logging console, or logging buffered is logging buffered is debug, because I don't want to get swarmed with all these issues. So what I'm going to do now is I'm going to go on that same access list. I'm going to type in access list, and the name of the ACL is all these ciphers and your stuff that you're seeing. All of that is SNMP3 coming through. Oh, why did I wait? Let's just type it in here. Access list. Access list. Let's go ahead. Logging. Enable. No. Okay, logging has been disabled, so we're going to go and type in show access list, and we're going to type in access list line 2. Go ahead and line 2 extended permit ICMP any object private server 2, and just hit the enter key. We don't need anything more than that. So now that we've done that, after a moment of time, we'll do a show access list. We should see hits on the ICMP access list. We have a deny IP any implicit at the very bottom of that. So we know it's working. And if we were to come back over here to my this guy here and type in ping, I can ping to 10.1.10.100. which indicates that I can communicate through. If I hit the up arrow again, I have 5 more hits, and the ping responds this way. So the NAT is working the way it's supposed to. So this is a static NAT, okay? So I'm going to come in here, and I have to go and create another one for a static PAT. So show run NATs. Right now we have a static entry that says, and we do show NAT. We have, notice how when we configured it, it shows up from a logical perspective, configuration-wise, as the bottom one that we've configured, since it's a static public server 2. However, from an operational perspective, it's the first one in line because it's the most specific. So it goes from the most specific to the least specific, or the most generic. So I'm going to type in, I want to be able to reach test 12 via telnet. So I'm going to go ahead and type in show run object, and I'm going to go to object network test 12, and I'm going to type in NAT from the DMZ VLAN 30 to the outside interface. We're going to come in here and type in static, and then I'm going to say I don't have an IP address that I can, or I don't have an object per se that I can map. So I can just type one in. I can type in 10.1.10.12 because they're both end in .12 in both subnets. Then I can come in here and type in service and then specify the service is TCP. And if you look at the real, this is important, the first port number or application that you map to has to be the real port, TCP. So this is what test 12 is actually listening for, which is 23. Now the mapped TCP port could be whatever value I want to put in. I can put in 2323, for example, and hit the enter key. Now, with that done, my question to you is, with the way that the access list is written, show access list, do I have to create any entries in the ACL in order to allow that traffic to come through? The answer to that question is yes, I do. As a matter of fact, I have to exit out of here and type in access list ACL in from outside, hit the line, and I'll type in line 3. You don't have to type in line 3. You can just type in extended and permit TCP from any source to a host of test 12, and then say, sorry, I meant to say object, any object, and then say the equal to a port number if I wanted to. But because of the fact that I have already listed out that the flow is TCP 23, you'll notice that it just says the port number. So I'm going to say put in here 23. So any other flows that come through will be dropped. So show access list, hit the enter key, and there's 23 for telnet. Now if I open up a PuTTY session, and I bring this guy, give it a second to pop up, and I bring this over and I say 10.1.10.12 to port 2323 via telnet, click on open. This pops up. I type in Rob and Cisco, and there I'm on test 12. Now, if I do a show run section HTTP, you'll notice that HTTP is enabled. Now, if I was to go to Firefox and hit this page and go to resynchronize it, it's not going to work. Why is it not going to work? Exactly. It's not going to work because I've gone and only allowed telnet through the ACL. I haven't allowed web communication. So, but here's the funny thing about it. The funny thing about it is in my configuration for the ASA with the show run NAT config, my config is specific to test 12 via telnet. So I ask you guys, do you think it would make more sense to say static to an IP address and then use the ACL to lock down what the actual communication is? Because in reality, if I need to allow more than one service, if I need to allow more than one service to a particular destination, let's say I've got a server that's running, email, FTP, web, and any other type of transport that I needed to, or service that I needed to support, would it make more sense just to allow the NAT translation and then use the ACL to determine what it can do? I think so. So we're going to go in here and just type in this. And then we're going to exit out, show run NAT, just make sure that it took the config, and it did. We're going to do a show run access list. And we see in the access list, show access list, that we have these entries. Now what I get to go do is I get to go in here and type in no entry for this guy, right? Because I'm a big believer in cleaning up my config. If it's not necessary for it to be there, don't have it there. I can hit access list ACL in from outside, extended, permit, any type of TCP flow you might want to say, from any to a object of test 12. But here's what I'm going to do. I'm going to put an object group at the end here and call it TCP flows, is what I believe is this one, TCP flows, and hit the enter key. Now if I do a show access list, you're going to see this ACL entry added. Now, at the same point in time, if I tried to ping that address, if I tried to ping from here, if I tried to ping .12, it's not going to work because there's no entry that's allowing ping through. So this is one of those other times where you'd have to come in here, hit the up arrow, and you'd have to go pull this guy back to here, and then you'd have to come in here, permit ICMP. Now hit the up arrow again. Now the ping will respond. And now that I have all that in play, I should be able to go and open up, and let's go ahead and close session. Let's go ahead and quit. I'll open up another putty session just to prove that it is actually working the way that I say it does. We'll type in 10.1.10.12 to port 2323, and we'll click on open. Now, why is that not working? It's not working because I removed the specific service mapping. So now all I have to do is say, close this out, open up a new putty session. I should be able to type in 10.1.10.12 to 23 and click on open and bring this guy over and type in Rob and Cisco. That pulled up, and we hit the up arrow and we show access list. We see an entry for Telnet. Now if I go over to Firefox and I resynchronize this, sorry, 8080 is incorrect too. So let me go ahead and close that. Stop this one. I get a pop-up. So Rob and Cisco, hit the enter key, and then I get a pop-up there. Now I come over to the ACL. I hit the show access list, and now I've got hits on www and Telnet. So if you need specific NAT entries for specific ports, that gets configured underneath the NAT configuration. So show run NAT again. If I do this, I need to make sure that if I need a specific server to be able to NAT to a specific IP, I need to state that in my NAT configuration. But I also need to make sure that in the ACL that I make sure that those ports are opened when I go to allow the communication. And that's where you use the ACL to come through and do its job. So like for instance, I don't have it in here, but if I was to come in here and say, let me go do network infrastructure, let me go and type in add device. I'll come in here, I'll type in the name of the device. Here is going to be test 12, and the IP address here is 10.1.10.12, and it's going to be just a router. I'm going to go ahead and click on we're going to do that, and then we're going to go ahead and click on OK. There's really nothing else for me to do, and it's going to go ahead and auto-discover it. So it should be able to, yeah, test 12. It should be automatically able to discover it. Now, one thing that I'm not doing on the device is I'm not running Snmp. So if I was to enable Snmp on the router, it should allow communication to it, and it should allow it to see what's going on, you know, bandwidth, interfaces, all that type of stuff will be discoverable. So now, but what's interesting here too is in our NAT config. So the ping is automatically working. We see the ping, well, it's not automatically, it's close to it. We come in here, we hit the show access list. We should see ping coming through and talking to the device. So that's working. So that's pretty much everything that we needed to have set up in order for us to work. Now, that's basically the idea that we're trying to accomplish here. We've accomplished that goal. We know what's going on. We know how to configure it and stuff like that. Now, there are two other types of NAT that we haven't discussed yet. We're only going to discuss one of those two, which is going to be the manual NAT, show run NAT. And what we're going to do is in the next video, we're going to do a manual NAT after we create the VPN connection, and there's the test 12 is now pinging on a regular basis, so we know NAT's working. We're going to do that, and then what that'll allow us to do is you'll also see too, I want you guys to see this, that when we're talking about allowing traffic from the outside in, these untranslated hits are outside to in. This communication of 10.1.10.12 to 172.16.30.12, there's 38 untranslated hits. Untranslated means that it came in on the outside and was translated in. There was an access list that allowed the communication through, and that's really all that matters. So what we're going to do in the next video, everything's up and running already. It's just a matter of us going through and configuring it. I've got the configuration for the cryptography already ready to go. I copied and pasted it out of the ASAs when I was doing it so that I wouldn't have to retype it all in again. So we're going to do that, and then we're going to create a manual NAT entry in the section 1 table of the NAT table, section 1 of the NAT table, so that when we go to NAT ping between go full screen, test 9 and test 15, the traffic from test 9 isn't natted out to the internet. We're not natted effectively, and I'll explain how that works when we get there. So that's the next video. Thanks so much for stopping by, guys. And until next time, take it easy.